Yes, children, good morning. My name is Rambabu. I'm a chemistry teacher. Today, we are going to learn one topic in chemistry, which is very important for SSC exams. From this chapter, definitely one question. Every year, one question will come for 4 marks. Such a very important topics about we are going to learn today. Today, we are discussing about chemical bonding, children. Then what is the chemical bonding? Before going to this topic, we should know little bit information about chemical bonding. Okay, now as of all children, that means whole universe is made up of matter. Okay, now well, children, whole universe is made up of matter. Okay, now whole universe is made up of matter. That matter is made up of elements, well. Okay, na? That matter is made up of elements. Okay, again children, these elements again made up of atoms. What those are? Atoms. Then what about atom, children? Atom is made up of small particles. What particles those are? Small particles, electrons and protons and neutrons. Okay, well. Electrons and proton, neutrons. Okay, na? Simple form, children, you can write electron means E- and proton means P and neutron. Okay, now children, whole universe is made up of matter. Matter is made up of elements. Element is made up of atom. But atom is made up of small particles. What those are? Electrons and protons, neutrons. Well, matter is made up of elements. That matter is having a mass and space also, as well as elements. Elements also, children, having a mass. Then an atom, children, tiniest particles. Then what is the definition of element, children? The element is a pure substance which we can't separate by using any physical methods and chemical methods. Okay, such type of material we'll call it like as an element. What is that, children? The pure substance. Element is a pure substance which we can't further divide it into by using any physical and chemical methods. Understand? Now, atom is what, children, definition? The atom is the smallest particle. Okay, na? Very tiniest particle. Again, which we can't separate it further new substance. Okay, na? Such type of particles will call, children, atom. Again, this atom, made up of, children, electron, protons, neutron. Atoms inside, these three all there. What those are? Electrons and proton, neutron. Okay, what is the relation and our chemical bonding that these means? These elements will be there, these elements, and two or more elements combined together, forming a new substance. Okay, na? Forming a new substance. Only elements. Okay, na? Two or more elements combined together forming a new substance. About those we are going to learn now. One by one, we will learn now. Okay, na? Good, children. Okay, first one, children. Till now, no? Then why we need to combine elements? To get stability. Well, children, in our periodic table, total 118 elements are there. Yes, 117, 118 elements are there. Those are all elements, children, does not exist independently. Does not exist individually. Okay, na? Will combine together only can exist in our atmosphere. Well, that's in earlier topics you learn, in earlier classes you learn. Okay, na? Then existing nature not being individually elements. Okay, na? Combined only can exist. The combining nothing but, children, chemical bonding. If you see definition, children, of chemical bond, what is the definition of chemical bond means? The force of attraction between of two atoms will call chemical bonding. Okay, the force of attraction between of two atoms. The two elements will have say different elements or same elements, whatever. Their inside atoms will be there, no, in between a force of electrons. We'll call it like as a chemical bonding. Okay, na? Then element means, no, two or more elements together is forming new substance, no. Now we are going to learn now. What is that, children? Formation of ionic bond. Totally, children, chemical bonding, no, divided in three types. What those are? An ionic bond, covalent bond, coordinative bond. Coordinative covalent bond. But in your textbook, no, only given two bonds. What those are, children? Ionic bond and covalent bond. Did not give in coordinative covalent bond. In next classes, in higher studies, in intermediate will be. Then, no, first we will learn about, children, ionic bond. How many types of bonds, children? Ionic bond. Ionic bond. First one ionic bond. Second one covalent bond. In your textbook, these two about only given, children. These two about we are going to learn now. First one, children, ionic bond. Okay, what is the ionic bond, children? Ionic bond means, no, there only there ions. The changing of ions. Okay, no? Or changing of electrons. Or changing of radicals. We'll call it like as a ionic bond. In between, children, in between elements will be there, no? In between of element, the changing of ions. Okay, no? Changing of ions. Or changing of electrons. Okay, no? Transfer will be there. Transfer. Such type of process will call, children, ionic bond. Okay, no? Just one, children, what is the definition means, no? The changing of ions. Changing of ions is called as a ionic bond. Ion means what, children? One cation, anion together will call it like as a ion. The cation ion changing or transferring will call it like as a ionic bond. Okay, na? First one, children, formation of ionic bond. Formation of ionic bond. Children, first one in chemical bonding, no, first one which bond? Ionic bond. In that ionic bond, first one we are learning, children, the formation of ionic bond. Ionic bond means what, children? What type of elements will participate here, children? Which type of elements will participate here, children? Ions. Ions means and cation, anion means called ions. Such type of elements only will participate here, no? Which is example will comes in under, children? Sodium chloride. First example, children, sodium chloride. Okay, na? Then NaCl. Sodium chloride is a common chemical formula. Sodium chloride, NaCl chemical formula, sodium chloride, no? Name is sodium chloride, no? And formula is NaCl. You know that, children, sodium atomic number 11 and chlorine atomic number 17. Of course, children, earlier, no, we mentioned one point in our periodic table, no, elements does not exist individually. Does not exist individually. Okay, now is there any stable elements are there? Yes, there. What those are? Yes, 8th group elements. In our periodic tables, no, divided group first, no, 8 groups include and subgroups 18 groups. Main groups 8 groups are there, no. 7 periods are there, no. In those an 8th group elements, children, and stable elements are there. Why we are calling to them as a stable elements, children? In between of elements and the 8 electrons are there. The which will element will have 8 electrons in between in there in valence shell. Such type of elements will call it, children, octet electronic configuration or octet elements. Okay, na? What those are, children, elements? Which group? 8th group element, children? Helium, neon. Okay, na? What those are? We'll see now. And helium, neon, argon, and krypton, and xenon, radon. These are the, children, 8th group elements. Okay, these are the 8th group elements. That means what, children? These and 5 only children 8th group elements. So why means no, in bit, of course this one also 8th group element only, but in between no, in these elements no, 8 electrons will be. In between no, 8 electrons will be. In helium children, in helium no, only 2 electrons will be. You know well, helium atomic number how much? 2 no? Then how electrons will be in this one? That's why no, we will call it them as like as a helium duplet electronic configuration. Only helium children we will call the duplet electronic configuration. Except these elements, remaining all elements we will call it like as a octet electronic configuration elements. There are many names are there, you know well no, what those are? And rare group elements, inert gases, zero group elements, eighth group elements. Okay, na arrows also. Many names are there, no? Such a many names are there due to the stability. Due to stability. What stability children? In between no, in there no, 8 electrons will be there. In valence shell, in their valence shell no, 8 electrons will be. And every element, in which elements will have 8 electrons, those elements we will call it like as stable elements or stable electronic configuration. That's why no, these 8th group elements no, does not react with any other elements. Does not combine with any other elements. Except these, remaining all elements no, combining with other elements can form new substance. That is only we are learning in chemical bonding. Okay, na? Those only there in ionic bond, covalent bond, coordinated covalent bond. Okay, na? First one we started like as ionic bond. Transferring of ions or changing of ions. Okay, na? Cation and anion together we'll call ion. Okay, na? Ionic bond. Okay, first one children we have taken like as a formation of ionic bond. Example children, sodium chloride. Sodium which group element children? You know well children, in periodic table no, S block elements, P block elements together no, can give n number of substance, n number of compounds, you know well. Okay, na? S block element, P block elements. Now in sodium chloride, which is S block element? Sodium is S block element. Chlorine is P block elements. Okay, na? Sodium S block element children, electropositive elements. Means no, and S block elements, all elements no, losing capacity will be there. And chlorine children, P block elements. All P block elements no, gain electrons from S block and metals. Okay, na? P block elements means chlorine children non-metal, and sodium means children S block elements metal. Okay, now metals mean children electrons losing capacity will have. Non-metal children electrons gaining capacity will have. Okay, now how we will see now children? You know well, sodium atomic number 11, electronic configuration 1s2 and 2s2 and 2p6 and one, take it count children, 3s1. Yes, no? You know how to write electronic configuration each of every element? That sodium atomic number 11 no, and 1s2 and 2s2 and 2p6 and 3s1. Okay, na? By using Euler diagram we will write no, electronic configuration. That Euler diagram helps to write electronic configuration no, in this order you have to write no. And take it count children, 2 plus 2 to 4, 4 plus 2 6 10, 10 plus 1 is 11. 11 is sodium atomic number. Come to the chlorine children. Okay, this one is sodium. Next to chlorine. Chlorine children, 1s2 and 2s2 and 2p6 and 3s2. Next to 3p5 children. One check it children. Okay, this one children, 2 plus 2 to 4, 4 plus 2 6 10, 10 plus 2 to 12, 12 plus 5 17. Okay, na? Chlorine atomic number 17 no. You know children, here no outermost valence shell children, how many valence electrons are children? When you are writing one element electronic configuration no, whichever outermost shell will be there no, we'll call it like as a valence shell. Our last one we will call it like as a valence shell. In their electrons no, valence electrons. Understand children? Now which is valence shell children? 3s to 3p5 is valence shell. In those electrons how many are there children? 5 plus 2 7 are valence electron. Okay, na? Here children 3 3, but here children and sodium no, what is the valence shell children? And 3s1. Then why you are not taking 2s to 2p6 here? Already 6 plus 2 8 are there. That too, and 2s and 2p6. P orbital you know well, filling capacity only 6 electron. Already it can filled. Already it has filled. It had filled also. And 2s2 also 2 electron filling capacity. Already it has also filled. Okay, na? Then children, here one, how many electrons are there, children? 1 electrons are there. Children, once imagine, okay, na? Sodium should get stability. Means no, more 7 electrons required. More 7 electrons required. Okay, na? Chlorine, children, should get stability means no, more 1 electrons required. Okay, na? Once listen, children. Here no, here 7 electrons gaining easy, 1 losing easy. Once imagine here. Here only 1 electron having from sodium is outermost valence shell valence electron. Sodium individually it should get stability means no 7 electrons required. That means no, at 7 gaining easy now, 1 losing easy now. Once imagine. Obviously no doubt at all. 1 losing only easy for sodium. Almost P block elements, S block elements means metals. Metals losing capacity only will be there. Yes, losing capacity only will be there. Like no, 1 can lose here. Then come down here, children. Here chlorine is P block elements, non-metals. Means non-metals means what, children? Then no, and chlorine, children, valence electrons, how many came, children? 7 came. Here, children, 7 losing easy, 1 gaining easy, children. Once imagine. The 7 number is more, no? If we get 1 means that 1 number is single, no? If you get 1 means easily can stable, no? Like children, then no, this 1 will come and will add here. Total how many children now? 8. What is our rule, children? When an elements between 8 electrons combining or sharing or transferring, if the became number 8 means, okay, na? We'll call it them like as a octant electronic configuration. Octant electronic configuration. Let's understand now. Then 7 plus from chlorine, 1 plus from sodium, together 7 plus to 8. Once imagine, children, after losing these 7, after losing this 3s1, here 2s2 plus 2p6 and 2s2 plus 2p6. Here also it is there, here also it is there. All together also 8 is there. Now can we call it them as a compound? What's happened here, children? Chemical bond is formation on, ionic bond formation on, 1 means what, children? Sodium means plus will be there, no? And positive nature is there, no? 1 electrons losing, no? Chlorine means negative nature, no? Negative nature, not. From sodium, no? Electron will come and chlorine, no? Electron will take. Okay, na? This is the, children, formation of ionic bond. Okay, na? First example, children, we have taken like as a sodium molecule, sodium chloride molecule. Okay, na? Next example, children. First one just now we have completed that formation of ionic bond in sodium chloride. Okay, now second examples we are going to take, children. That one is second one. Okay, formation of magnesium chloride. Formation of magnesium chloride. Okay, na? You know well, children, magnesium also again and S block element in metal and chlorine also again and P block element in non-metal. Okay, na? Then ionic bond means in chemical bond 2 type of bonds, no? Ionic bond, covalent bond, coordinated covalent bond also, but which is even given in textbook, no? 2 types of bonds only. Okay, only we are learning about ionic bonds. First one we have completed in formation of sodium chloride. And second one is the formation of magnesium chloride. Magnesium is a S block element in metal. Chlorine is P block element in non-metal. Okay, now you know well, children, magnesium atomic number is 12. Magnesium atomic number is 12. Okay, now start write electronic configuration, children. Okay, now 1s2 and 2s2 and 2p6 and 3s2. One check it, children. What type of electronic configuration will come? Magnesium atomic number 12. The electronic configuration 1s2 and 2s2 and 2p6 and 3s2. Take it count, children. Only charge up values only we have to take it that atomic number. Okay, na? 2 plus 4, 4 plus 2 6, 10, 10 plus 2 12, which is a magnesium atomic number. This is the electronic configuration. Okay, na? Children, magnesium should get stability means Here no, outermost valence shell, which one children? Not 2p6 and 3s2. And 2s2, 2p6, x6 plus 2, 8 is there here. And which is the children? Valence shell here, n2, 3s2. This one is the valence shell. Inside how many electrons are there children? 2 electrons are. Those we will call it like as a valence electron. In magnesium children, 2 valence electron is there children. If should get stability means no, more 7 electrons, 6 electrons required. Okay na? It should get stability means no, more 6 electrons should required. That means 2 losing is in a 6 gaining is in a. Once imagine children. And 2 losing only is in a. Anyhow, magnesium is metal. Electropositivity. Donating nature will be there. Can lose of electrons will be in metal side. Okay na? 2 lose electrons from magnesium side. Then who will take children? Chlorine. 2 chlorines are there no? You know well. Chlorine atomic number means what children? Chlorine atomic number is 17. Okay na? So I'm starting to write children again electronic configuration. 1s2 and 2s2 and 2p6 and 3s2 and 3p5. One take it count children. 2 plus 4, 4 plus 2, 6, 10, 10 plus 2 to 12, 12 plus 2, 5, 17. Okay na? Then valence orbital children 3s2, 3p5. Valence orbital 3s2, 3p5. Then valence electron how many children? 5 plus 2, 7 electrons are there. From magnesium side 2 electrons are there. From chlorine side 7 electrons are there. But here no, 2 chlorines are there. Twice we have to take chlorine no? Twice we have to take no? Then chlorine is again 17. Again we have to take 1s2 and 2s2 and 2p6 and 3s2 and 3p5. Same here also valence orbital 5 plus 2 3s2 3p5 valence electrons again 7. Okay now, in each chlorine side 7 are there children. Here 7, here 7. If it get 1 electron, it will get stable. It will get 1 electron, it will get stable. Okay now, 2 electrons required from chlorine side. Okay now, from where we'll take 2 electrons from here children? Non-metals means p block elements acceptor. Means no, we'll take electrons from metal side. Okay now, from metal side which one children? Magnesium 2 electrons are there. In each electrons no, and here 2 electrons are no, 1 will come and join here, here no, 8 will become, again no, 1 more will come and join here, here 1, total 8, and 6, 7 plus 1, 8, 7 plus 1, 8, like no, 7 plus 1, 8, 8 here, 7 plus 1, 8, then, so magnesium chloride is a stable compound. Okay na? In this way children, formation of ionic bond will be. In this way, formation of ionic bond will be. Okay? And first one children, formation of sodium chloride we have seen. And second one, formation of magnesium chloride we have seen. Okay now? Like this children, changing of electron, changing of ions. Changing of ions no, will form a new substance. Will form a new compounds. Changing of ions means what children? Magnesium having plus 2 electrons. Chlorine minus 2 electrons less are there. Okay now, from magnesium 2 will come and will join here minus 2. Once check it children, how it will be there. And here once I am writing here magnesium plus 2 electrons and chlorine minus 2 will be there. The same number will come here. For example, no, I think here 3 electrons losing, here 2 will not take like, okay na? How many are losing here, those many will take here. Okay na? 2 electrons losing here, 2 electrons will take from non-metal side. Okay, this is the formation of magnesium chloride children. Okay na? In ionic bond children, 2 examples we have seen. What those are? Formation of sodium chloride, formation of magnesium chloride. Okay na? And next children, one more examples we will see. Okay, third examples we are going to take children. The example is, which one that? Formation of magnesium oxide. Formation of magnesium oxide. One check it children. Magnesium is, as of you know, magnesium is atomic number 12. The electronic configuration is 1s2 and 2s2 and 2p6 and 3s2. Yes, 1s2, 2s2, 2p6 and 3s2 is a magnesium atomic element configuration. Next, come to the children, magnesium oxide, no, and magnesium is a plus 2 electron having minus oxygen, no, minus 2 electrons will be there. Okay, now the magnesium 2 electrons can lose, oxygen, no, 2 electrons can take. How we will see. Okay, now then valence shell is 3s2 children, 1 orbital, that electron children, 2 electrons. Okay, come to the oxygen now. Oxygen is children, okay, now oxygen atomic number is how much children? Atomic number is 8, no? And 1s2 and 2s2 and 2p4. Yes, 2p4 and 4 plus 2 6, 6 plus 2 8. This is the oxygen atomic number electronic configuration. Okay, now then what is the valence orbital children? 2s2 2p4. 2s2 2p4. 4 plus 2 6 are there. More it should get stable means. So how many electrons required? How many electrons required? 2 electrons required, no? Then 6 losing easy, 2 gaining easy. 2 gaining only easy, no? Obviously that it will take from magnesium. Magnesium side how many electrons are there? Only 2 electrons are there. Those 2 electrons will come and will join here. Okay, na? Then here 6 are there. Those 6 plus 2, how much? 8. And 6 plus 2, 8. Then becomes stable compound. Then becomes stable compound and at once check it. Okay, na? Formation of magnesium oxide. Magnesium is 2 electrons losing. Oxygen is 2 electrons are gaining. Understand? This is the way children to form ionic bond. Then now just we have seen children formation of ionic bond. Ionic bond means the changing of ions or transferring of ions. We'll call it like as ionic bond. Then what type of properties will have ionic compounds? Okay, now till now 3 examples we have taken, we have proved also. Then the physical properties we will see. Ionic compounds, what type of properties will have? Okay, physical properties. Ionic compound physical state children. Physical state. Mostly children, ionic compounds are crystals. What those are children? Crystal in nature. Crystal in nature means what children? In sodium, no sodium chloride. In what nature is available? Crystal in nature, you know? Like no, most of the ionic compounds are crystal in nature. The physical structure if you see means no, crystal in nature and solid at room temperature. What is that children? Solids at room temperature. Solids at room temperature. Next children, melting and boiling point. We'll see. MP means melting point, BP means boiling point. Okay, now? Then what type of melting points and boiling points will be in ionic compounds? Ionic compounds will have children high ionization, high melting points, high boiling points will be. Okay, now? The boiling points will be children high melting point and high boiling point will be. Okay, na? Metals and non-metal together is forming substance. So high melting point, high boiling point will be. Okay, na? Okay, high melting point, high boiling points will be. Next children, electricity children. Come to the one more property, electricity. When ionic compound children solid form can't pass electricity. When ionic compounds when is solid nature it can't pass electricity. When ionic compounds is molten state can pass electricity. Okay, na? Ionic compounds when is there in molten stage Then ionic compounds all are good conductors of electricity. Why in solids not possible, children? And solid nature is there in between of ions, no? Strongly packed together, no? There is no negligible space, no? Due to negligible space, there is a not pass electricity, should not pass electricity and will not pass also. When in molten state, then possibility is there. Okay, that means what, children? Ionic compounds all are, when in molten state, good conductors of electricity. In molten state, good conductors. Okay, these are the some of the physical properties, children. What those are, children? Physical states, which we have completed in earlier earlier examples, no, children. And formation of sodium chloride we have seen, and formation of magnesium chloride we have seen, and formation of magnesium oxide also we have seen in ionic compounds. Many of examples we have taken like as a ionic compounds. Okay, na? Then physical properties about we are learning now. Okay, na? Physical state. Physical state means what, children? Almost and all ionic compounds are crystal in nature is available and solids at room temperature. Okay, na? And strong nature will be solids at room temperature. Then what melting points and boiling points will be the, children? Ionic compounds, no, mostly will be high melting point or high boiling point will be. Okay, no? High ionic compounds all are, children, high melting point or high boiling point will be. Okay, na? Electricity, children. That means electricity means what, children? And solids can pass electricity through them? Not possible, no? When the solid nature is not possible, no? That means, no, many of metals, many of solids we are telling, no? Almost, and when solids nature is there, no, not possible to that much. When is molten stage, no, all ionic compounds can pass electricity through them. These are the properties of ionic compounds. This is the, children, in chemical bonding, no, ionic compound about brief explanation. What we have seen, children, what we have learned, ionic compounds definitions, ionic compounds features, formation of ionic compounds, and formation of examples, and properties of ionic compounds. Okay, na? I hope everyone understand. Thank you so much, children. I hope everyone understand this topic, which we discussed, which we learned now, which we have taken examples. I think you all understand these all topics. Very, very important, children. And every year, no, one state syllabus, no, and one SSC exam paper will be there, no, physical science. There definitely one question will come from chemical bonding. Very, very important. Such important topic, no. Everyone should learn this topic, should listen these topics. Okay, na? One should go through on this topic. Okay, na? Thank you so much.